Let's take a look here at extrema, which are the biggest or smallest values. So jumping into that, extrema are also known as minima and maxima, and these are the largest or smallest values. And as you would expect from kind of normal English, maximum is the largest value, and minimum is the smallest value. We have two types of extrema. The first are local extrema, which are just compared to nearby points. Sorry, that's looking a bit rough. So the biggest or smallest value when compared to the points right next to it. Then we also have global or absolute. Both of these words get used. Extrema, and that's compared to the entire domain. So all of the entire range, I guess technically. So compared to all of the possible points, what's the biggest or the smallest? So this is going to be important in a minute here, but just kind of make sure you store that away. Local just looks at nearby. So for example, actually let's jump into the example here because this will help show it. A function may have both an extreme max and an absolute max and an absolute min. It may have only one extremum, only one minimum or maximum, or in some cases, neither. So let's do some examples of this. If I have something that looks like this and continues forever, this has no absolute maximum or absolute minimum because these functions continue forever. There's no maximum value. They always get bigger, they always get smaller. It does have a local maximum and a local minimum though, because compared to the points right around it, this is the biggest out of all of them. Compared to the points right around it, this is the smallest. Something like this with defined endpoints also has an absolute maximum and absolute minimum, but it doesn't have local maximums and minimums because we don't have any information about the sides. So in order to be a local maximum or local minimum, you have to have values on both sides. So this is just absolute max and absolute minimum. Something like this, where that continues, has an absolute minimum, which also happens to be a local minimum, but no absolute maximum. And I think that pretty much covers all of our bases. I guess something like this has no local minimum, no local maximum, no absolute minimum, no absolute maximum. So there's a lot of ways that these can be distinguished. If you want to talk through them more or make sure you have things kind of squared away, let me know in class. The extreme value theorem says that on a closed interval, if a function is continuous on a closed interval, and we'll call that interval a comma b, it must have both an absolute maximum and an absolute minimum. So if you have a closed interval, that means you have something like this. There has to be a maximum and minimum because basically all the points are defined, so one of those numbers has to be biggest. The kind of counter case to this that does not meet the conditions because it's an open interval, if you have the open interval AB, you don't necessarily need a maximum minimum because in this case there's no minimum because you get closer and closer and closer to this point, but you never actually reach that point. Same thing with the maximum. You get closer and closer and closer to the maximum value, but since it's not defined here, you never actually get a maximum value. But again, this isn't being discussed in the extreme value theorem because we're looking at a closed interval. So let's do some examples to make this kind of track and make sense. Find the absolute maximum and absolute minimum from the interval 1, 3 for the function negative x squared plus 3x minus 2. Well, now we know that our absolute minimum and absolute maximum, they have to occur at critical points or at the end points, because critical points are the only places that we can get, you know, a local minimum or a local maximum, because that's where a peak or a valley is going to occur. That's where you're going to go from one direction increasing to a different direction decreasing. So we're going to look at critical points, and we're going to look at endpoints, because it could also be one of these two endpoints. So first, let's find our critical points. F prime of x is equal to negative 2x plus 3. We'll set that equal to 0. That means x equals 3/2. So that's one of our critical points. And we also need to consider the endpoints. X equals 1. Oh my gosh, I don't know what's happening there. I think my tablet's getting fussy with me. Let's try that again. X equals 1. X equals 3. So now, in order to evaluate, we just have to kind of plug them into the function and see what's the biggest and what's the smallest. So for x of 1, 3/2, and 3, f of x is equal to, for 1, it's going to be 1 plus negative 1 plus 3 would be giving me a 0. 3/2 is going to give me 1/4. I've done this ahead of time. You can double check my math. And negative 3 will give us negative 2. So this is nothing. This is our absolute max, or our global max. And this is our absolute or global min. And again, we check our critical points, we check our endpoints, and then we just plug them in.